Okay, so let's see how we can solve another question from the third chapter of the engineering mechanics by Meriam. So we have a force P on the handle of the positioning lever that produces a vertical compression of 60 pounds in the coil spring. And the position shows, so we're talking about this is string. So we have the force of 60 pounds in compression, and we need to determine the corresponding force exerted by the pin at point O. So we have a pin at point O, which means we're going to have one vertical component and one horizontal. Basically, the question is asking us to find that force. We are in equilibrium and we have three unknowns in here and three equations. Our equations are sum of all forces in x equals 0, same for y, and we're going to have one moment equation, which means we can find up to three unknowns. So let's start with the free body diagram of the whole thing, and here we have a pin, which means we have OX and OY. Let's just call X and Y axis here. So OX, OY in here, since the spring is in compression, so the spring by itself is in compression, and that's the force that is applying from the lever to the spring. So the force that the spring applying to the lever is going to be in this direction, and we know the force is 60 pounds. I'm just going to clean this up. And that's pretty much all the forces that we have. So we're going to start with our moment equation first, because if we do the moment about point O, we're going to get rid of all the unknowns at point O, so we should be able to find the P. And after P, if we do sum of all forces in X, we can find OX. And if we just do sum of all forces in Y direction, we should be able to find the Y. So if we want to find the moment about O, we're going to have the moment of the P, which is going to be a counterclockwise moment. So positive P times the position vector, the vertical distance from O to the line of action, which is going to be 8 inches. And we're going to have the moment of the 60 pounds about O. This one's clockwise, so negative 60 times vertical distance from O to the line of action, which is 3.2. That's going to be equal to 0, and we can cancel this out. This is going to give us 0.4, and our force P is basically 6 times 4, or 24 pounds. Now that we have the force P, we can do sum of all forces in X, which we're going to have OX minus P equals 0. So OX will be 24 pounds as well. And one last equation, sum of all forces in Y equals 0. That's going to be 60 pounds upward plus OY equals 0. So OY is going to be negative 60 pounds. The negative sign shows that OY is actually in this direction. So our assumption at the beginning for positive OY was incorrect. So if we just want to find the O, we're going to have the square root of OX squared plus OY squared, which is going to be square root of 24 squared plus 60 squared. Let's see what we get. So the square root of 24 squared plus 60 squared, this is going to give us 64.62 pounds and the magnitude of the force at pin O. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.